Okay, welcome back to ITP 115, Programming in Python. This is the second part of 2 on functions and the second part of 3 videos. In this video, we're going to be talking about immutable variables. So in the last video, we said we want to keep function and variable scope as local as possible to make debugging easier in order to find where state of variables changed. And one way of doing that, the most common way of doing that, is through parameters and returns of functions. And how a parameter and return of a function behaves, it depends on whether or not that variable is mutable. And in order to really understand the concept of mutability, we need to first understand that the concept of variable references, and that a variable does not actually store the data you assign to it. Instead, it stores the data in memory, and then these variable names that we're used to dealing with are really references or pointers or labels to that memory spot. You can think of it as like we deal with like item numbers in IKEA in the showroom floor, but it's actually sitting somewhere in a warehouse. Okay, that's one way of thinking of like variable references, right? That card that you pick up in the showroom versus like sitting in a physical warehouse somewhere, that would be computer's memory. And everything we learned in the last video about namespaces also applies to the memory and the references, right? The reference exists in the current namespace. So here is a visualization of that, right? When we have code like this, and we say we are going to make a variable called num and assign it the value 45, what's really happening there is 45 is going to get some spot in memory, and then in our namespace, in this case main, so num would be a local variable in the function main, okay, visualized like this, okay. Num is a reference to that spot in memory. It is a label or a pointer, right? This is just something, a card in your hand that's pointing to a spot in the warehouse, right? A variable reference to a spot in memory. This variable num is referring to a spot in memory. So when we pass a variable reference to a function as a parameter, immutable variables, okay, are not affected, right? And remember, immutable, right? Immutable means not mutatable. In other words, not changeable, where change is defined as changing just one part of that variable. Okay, so how things behave inside of a function and whether or not that change will persist to after the function call depends on whether that parameter that you're passing is immutable, mutatable, changeable, or mutatable, changeable. Okay, so not changeable, changeable. And immutable, right, means not changeable. So in other words, not going to be affected by any changes that we make inside of the program, inside of the function. Whereas mutable variables, mutatable, changeable, may be affected by the changes inside of a function body if we are using modifying operations like random item assignment right here, like some list at some index equals a new value, appending, removing, removing by value, deleting by index, etc., will affect the original variable outside of the function. Whereas assignment or reassignment is a whole new spot in memory and will basically behave, reassignment will behave like immutable. And we're going to see examples of all of these. Okay, so immutable objects, not mutatable, not changeable, right? When you reassign an immutable object, it creates a whole new spot in memory. So when we use this equal sign, assignment, it's a whole new spot in memory. Immutable examples of immutable objects that we've seen so far in this class are ints, floats, and strings, and also tuples as an aside, as a reference. So here's a visualization, right? Suppose we had a line of code num equals 45. So what happens there? Well, we already saw, right? We get num, a reference to some spot in memory. Then if we were going to do num equals 81, you would maybe think that 81 is just going to just overwrite this spot in memory. Now remember, num is of type int is immutable. So when we do what's called reassignment here, we are actually creating a whole new spot in memory and writing that new value there, and then num is now pointing to a new spot. Okay, so we've updated our pointer or our reference or our label of this new spot in memory. So this is a whole new copy. Okay, that's important when we talk about passing an immutable object like an int or a float or a string to a function, right? When we do that, a copy, right? A copy, a whole new spot in memory is created and the pointer or the reference is updated to that new spot. Okay, right? And since the object is mutable, any changes to this value inside the function will not affect the original variable outside of the function. So let's look at an example here. If I have some code where I have some argument is equal to the value 25, that's this part here. Okay, let me jump into slideshow view here. All right. And okay, so this is that part, right? So we have our argument pointing to some value 25. Then we are going to, and this is why it's called passing, right? We're going to call my function here, passing in, right, this argument here. We're going to pass to its parameter, right? Parameter is now equal to 25, right? So we have parameter and argument both pointing to the same spot in memory. Okay, and now we can go ahead and print out 25, and it will print 25, no problem. And then if we print out argument, it'll print out 25 because you have basically two references pointing to the same spot in memory. Okay, but what happens if we try to change? Okay, what happens if we try to change an immutable object inside of a function, right? Remember, we define arg out here, outside of the function, then we call the function here, right? Pass it over to here, and now we're trying to change it. So now we're about to execute this parameter equals value 32. All right? Remember, a whole new spot in memory gets created. And now inside of the function, the local variable parameter is now pointing, right? Is now pointing, and it in its namespace is pointing to a completely different spot in memory. Whereas argument over here, and over here is pointing to that original value, the old spot in memory. So when we print it out inside of the function, it'll print 32. But when we come back after the function call here and print out argument is still printing to 25. So this is why we say immutable objects do not change inside of a function. Now there is a way around this. There is a way to make it so that we can make changes inside of a function and have them persist after a function, and that's with what's called mutable objects. In this class, that will be lists and later dictionaries, and we'll cover that in the next video.